Hello, in this AV we are going to do the numericals of exercise 7C. Now before we do the numericals, I have jotted few points for you which we need to remember. First of all, we will be using this formula that is known as mirror formula. 1 by focal length is equal to 1 by object distance plus 1 by image distance. Focal length is denoted as F, object distance is denoted as U, and image distance is denoted as V. Now if you understand the sign convention thoroughly and properly, then these 2 points you don't have to remember. In case you have slightest of doubt, then please remember these 2 points. Whenever we are talking about concave mirror, then U and F are always negative. V, that is the image distance, is negative for real image and positive for virtual image. And when we talk about convex mirror, then U, that is object distance, is always negative, but the image distance and focal length, they are always positive. Another formula that we are going to use here is for magnification. Now magnification is given as length of the image divided by the length of the object, or minus V by U, that is image distance by object distance. So this formula and mirror formula will help us solve the numericals for this exercise, that is 7C. Now for real image, please remember that magnification is negative. Whenever we find that magnification is negative, we have to know that it is a real image, and for virtual image the magnification is positive. So please remember these points and let us start the numericals. Now the first numerical says the radius of curvature of a convex mirror is 40, find its focal length. So we have been provided with radius of curvature, exercise 7C, question number 1. They have provided us the radius of curvature, that is R. R is equal to 40 centimeter, that is given to us, and they have asked us to find its focal length. So we know the formula that relates R and F. We know that focal length, either we can write R, radius of curvature is twice the focal length. So focal length will be, therefore focal length is equal to R by 2. So R is given as 40 centimeter. So 40 divided by 2 is 20 centimeter. So the focal length, or the answer for question number 1 is 20 centimeter. Question number 2 will be done accordingly. Let us try to solve question number 3. Now question number 3 says here that an object of height 2 centimeter is placed at a distance of 20 centimeter in front of a concave mirror of focal length 12 centimeter. So we have been given the focal length, the object distance, that is 20 centimeter, and height of the object, and we have been asked to find the position, size, and nature of the image. So let us write the given things first. So here we have written the given things. The height is 2 centimeter, object distance is minus 20 centimeter. Here for concave mirror, U and F are always negative. So U is minus 20 centimeter and focal length is minus 12 centimeter. Now this question can also be done on the basis of ray diagram. So if you are thorough with the ray diagram, with proper measurement, you can get the answer very accurate, and you can use the ray diagram method also. Here I'll show you how to do it numerically. Now we know that The mirror formula is given as 1 by f is equal to 1 by u plus 1 by v. So we put the values along with the sign. 1 by f is 1 by f is 1 by minus 12 is equal to 1 by minus 20 plus 1 by v. That is the distance of the image. So 1 by v will be equal to minus 1 by 12 plus 1 by 20. Now after calculation we will get 16, 5 minus 5 plus 3. Alright, so here we are getting 1 by v is equal to minus 2 upon 60. So that is equal to minus 1 upon 30. Now this is the value of 1 by v. We need the value of v only, not 1 by v. So v will be just the reciprocal of this. So that is equal to minus 30 centimeter. But while writing the answer, we will not write this minus. We will simply write that the distance of the image is 30 centimeter. Now image distance, image distance 30 centimeter. We have been asked about the question number 3 says size and nature. So for size, what we can do is we will use the formula for magnification. So magnification, as we know, is given as minus v by u, or minus v upon u. So minus v is minus 30 and u is minus 20. So minus minus cancel out. We are left with 3 by 2. So we can write 1.5 centimeter. Now here what we can do is, this is the magnification. Now magnification has got another formula, that is m is equal to h2 upon h1, means height of the image upon the height of the object. So this implies magnification is 1.5 is equal to, this minus sign will tell us about whether it is a real image or a virtual image. Now 1.5 h2 is the height of the image that we have to find, and h1 is height of the object that is given in the question, that is 2 centimeter. So 2. So therefore height of the image is 1.5 multiplied by 2, that is 3 centimeter. Now the nature of the image is, it is real and inverted. How we know it's real and inverted? Because the magnification is negative. So magnification is negative for real images, and real is always followed by inverted, and it is magnified because the object was having the height 2 centimeter, but the size of the image is 3 centimeters. So this is magnified. Let's see the other type of question. Let's take number 5. Question number 5 says, at what distance from a concave mirror of focal length 25 centimeter should an object be placed so that the size of the image is equal to the size of the object? For this, we know from the ray diagram that if we place the object at center of curvature, then the image is also formed at center of curvature and is of the same size as that of the object. So we'll make use of that. Here they have given us the focal length, that is 25 centimeter. Now we have to find out the object distance u. Sorry, we have to find out at what distance would the object be placed so that the size of the image is equal to size of the object. So size of the object is equal to size of the image. So here you can write that we know that if the object is placed at center of curvature C, then the image is obtained at center of curvature C and is of the same size. So we have to find the point where lies the center of curvature. Now center of curvature is nothing but the radius. So R is equal to twice the focal length. We will be using this formula. R is equal to twice the focal length. We have been provided with the focal length. Here we don't have to be worried about the sign convention. So we simply write 2 into 25, that is 50 centimeter. So below you can just write that if the object is placed at 50 centimeter, then the image will be also at 50 centimeter. Then the image would also be obtained at 50 centimeter. That's all. Now we try the next question. Let's try number 7. It says a point light source is kept in front of a convex mirror. Now the mirror is changed and they are talking about convex mirror at a distance of 40 centimeter. So the distance of the object is 40 centimeter. Focal length of the mirror is also 40 centimeter. We have to find the position of the image. So for this, let us write the given things first. So we have written the given things, that is the object distance is, for convex it's always minus or negative. So u is equal to minus 40 centimeter and focal length is always positive. So we have written f is equal to 40 centimeter. We have to find the v, that is distance of the image. So we use the mirror formula. We have, or we know, you can write, we know the mirror formula is 1 by f is equal to 1 by u plus 1 by v. Now we substitute the value. 1 by f is 1 by 40 is equal to u is minus 40 plus 1 by v. We have to find 1 by v, so we keep it on one side, rest everything goes on the other side. So 1 by 40, this going that side becomes plus 1 by 40. Now we get 2 upon 40 or 1 upon 20. So 1 by v is 1 upon 20. So therefore v will be the reciprocal of 1 by 20, that is 20 centimeter. And since this is convex mirror, so the image will be formed behind the mirror. Now this is the answer. Let's try the other type of question. Now question number 10 says a concave mirror forms a real image of an object placed in front of it at a distance of 30 centimeter. So here u is equal to minus 30 centimeters of the size 3 times the size of the object. So image got magnified 3 times as the object. We have to find the focal length of the mirror and the position of the image. So here first let us write the given things and then we'll try to solve. So here we have written the given things, that is the object distance is minus 30 centimeter and size of the image is 3 times the size of the size of the image is 3 times the size of the object. Now instead of first finding the focal length, if I have to first find the focal length, I only have u, the value of u. I do not have the value of v. So rather than finding out the focal length first, let's first find out the second part of the question, which tells us to find the position of the image, that is V. Once we find the V, we can use it in mirror formula and we can find the value of focal length. So we know that the magnification is given as, magnification is equal to minus V upon U. We have the magnification, that is 3 times. So what we can write is 3 equal to minus V upon U is V will be minus and U is minus 30. So minus minus cancel and 30 into 3 is 90. So V is equal to minus 90 centimeter. So the position of the image is 90 centimeter. Now the first part of the question, which says find the focal length. Now 90 centimeter you can write in front of the mirror, or even if you write V equal to minus 90 centimeter, that will be correct. Now we find the focal length. So using mirror formula, we have 1 by F is equal to 1 by U plus 1 by V. Now we can simply put the values. 1 by U is given in the question, minus 30 centimeter. So minus 30 plus 1 by V is minus 90. Now if you calculate it, this gives LCM would be 180. So minus 2 minus 6, or minus 6 minus 2. Okay, so here this would give you minus 8 upon 180. This is 1 by V. So let's take the reciprocal. Therefore V will be equal to minus 180 upon 8. So that is equal to minus 22.5 centimeter. Sorry, 1 by F, the focal length. So here we can just write in words. Therefore the focal length of the mirror is 22.5 centimeter. Now you can do number 11 in the similar manner, and question number 12, 13 and 14 are of the same type. So we will try question number 14. It says the magnification for a mirror is minus 3, and how are U and V related? The moment you see minus here with the magnification, we know that this is a real image. So we simply write here, this is question number 14. Magnification M is equal to minus 3. So this means it is a real image. Now since this is a real image, we will simply use the formula of magnification and we'll find out how U and V are related. So we know magnification M is given as minus V upon U. So here the value of magnification is minus 3, and they have asked us to find out how V and U are related. So minus and minus cancel out, we simply cross multiply and we get V is equal to 3U. This is how they are, the U and V are related. That's all in this AV. Thank you so much. God bless you all.